Hi everyone. Good morning, good afternoon, good evening, or good night. Nice to meet you again. I am Dodi, your lecturer on basic computer course. And in this course, for this week, you learn a new thing in C programming. And I hope you get good exercises on what you have learned before. Last week you got your quiz and also some reviews a week before. And fortunately, this is a very nice day. Still doing some lot of work and doing some practice, I'm sure. So hopefully you'll enjoy this course for this week topic. So in this course, you learn about the pointers. This is the most powerful features on C programming language. So let's start what you learned today. So in this course, you will learn how to use pointers and some pointer operators, and also do your some deep knowledge on pointers and arrays, and how to pass arguments to functions by using references, using pointers in this case. And the last thing what you have to learn is how to make a dynamic memory allocations. So there are four topics that we'll learn for today's course. And before we start, uh, I'll remind you that pointers are among C's most difficult capabilities to master. So it's quite unique structure in C programming. But the good case is pointers enables program to accomplish pass by reference or to pass functions between functions and to create and manipulate dynamic data structures. Once that you can grow and shrink your data size, yeah, at execution time, not depends on the static structure like as array or ordinary variables what you have learned. Further, for this case, you can also make use the pointers into a more complicated structures like linked lists, queues, or stacks or trees. All right, let's begin. So, I'm sure that you're already familiar with scanf instructions. See this in this case, scanf. But before that, yeah, well, I will remind you that if you want to use a scanf as one of the input operator in or input instruction in C programming, it should be uh, assigned with the ampersand sign. Yeah, it is address operators actually. So pointers actually are used to access the memory. In this case, if you use scanf, so you access or you input something, data, through your input devices and put it in a certain location in the memory, and the variable will get to the data when you want to manipulate it or want to access it. But the main thing in this case, the pointers actually used to manipulate the address. Okay, so if you have ordinary variables like here, and you have some pointer variables like ptr with the indirection sign here, asterisk, and if you want to relate this address to your variable, then you can assign it through pointer operators. Okay, so in the previous example, for example, if you see the scanf here, the reference operator used is ampersand, meaning this is the address sign. Okay, so from now on, you can call the ampersand sign is an address sign or address operator. Then you can use it in your programming. Okay, let's see the example of the using of a reference operator in C programming. Here, as usual, you have standard ioh.h as your library, and put some variable, for example, var, and you have the value of the var is 5, assign it var equal 5, and then you can print it the variable directly using printf the value of var, and also you can add some information about the where is the location of var actually located in the memory. So you get to print the address of var by using printf ampersand var or address var. Okay, so the compiler will show you the exact location of the var variables located, and it is located in some this is some unique uh, numbers. Maybe other computers can show different values, depends on the memory assignment and addressing, and also the operating system you use. So in this case, that the address of a variable can be printed, can be manipulated, and can be related to some data processing. Okay. So let's have this example in C programming. Actually, you just open the C, dev C compiler and see how it works. Yeah. Okay. See, this case is value of a variable, integer variable here, and you can also print the address. Okay, by using operator %u. Actually, if you want to have the exact or the the more commonly used as a addressing format, you can also use %p instead of %u. Yeah, if we try to compile it, okay, and then run it, then the compiler will show the exact locations of your data, the var variables located here. Something in format in hexadecimal format, it is 18 bits. Yeah, it depends on your operating system actually. If you have a 64-bit operating system, then you have a double size in addressing format like this. Okay, usually it's used only 6 digits of hexadecimal. All right, I think it is quite clear that you already familiar with the operator using in pointer, in this case the ampersand sign or the address sign. So let's move on to our topics here. And sorry, the pointer variables actually as other variables can be defined or can be declared using some operators here, and declaration of a pointer is the same as ordinary variables. You write down the data type and the pointer variable names, but the name should be preceded by the indirection operator, in this case the asterisk sign. Okay, since pointers are variables whose value are memory addresses, so this is very important not to forget that every pointer should be preceded by asterisk sign or reference operator, yeah, and or indirection. So if you want to, for example, define a PPTR as a pointer, then you should put the reference operator or the indirection operator before the variable name, the pointer names. Okay, so in this case, integer indirection PPTR, you can read it from right to left. You can read it as PPTR is a pointer to integer, to some integer entities or to some integer data or object in the program. So this is a quite unique writing or defining variables in pointer, since all the pointer variables should be preceded by this indirection or reference operator. And you're also familiar with ampersand sign. It is the dereference operator or the address operator. And we can see that this two operators is very important when you deals with pointers programming. I mean, if you want to manipulate data through address and you use pointer of variables, then you have to be precise, put the correct operators here. Okay, and we recommend you personally that yeah, if you build your own program, then you can decide whatever names you use to your variable name, right? So it is quite free, but if you want to make it you know, a good habit, yeah, I mean that it is quite clear that the pointer is very special variable in the programming, and it is quite you know, confusing sometimes. So we recommend you to put a PTR with a large P as a sign that this variable is operator. Yeah, because there are some kind, yeah, some quite complicated programming, and you have a very long list, and you don't know which one is the pointer, which one is the ordinary variable. When you deal with array, of course, you can look it as the square bracket always follows the variable names, right? But in pointers, sometimes you can be confused. So it is quite good habit that you put in the letters PTR in pointer variable to make it clear that these variables are pointers and need to be handled appropriately. But well, if you build your own program, then it's up to you. Okay, it's just some suggestion from me. Okay, let's see an example. This is a source code to how to handle and put the data and also explain what is the difference between a pointer and the ordinary variable. In this case, you have one pointer, yeah, PC, and one ordinary variable integer C, and these two kind of variable can be connected using some assignment later on. But if you see here, the PC and C it has two locations in the memory, right? So if you declare integer in direction PC or pointer PC here, then it is located in a certain location in the memory. And if you declare also C, and it also has its own address. So there are two variables here. The PC is a pointer, and the other one is only integer variable C. And how to deals with these two variables? Well, you can see that C is equal 22. Then directly C has the content of 22 here. How about the address? The address of C, you can print it as address C or ampersand C, and the value of C, just call it C here. Yeah. So the address and value can be printed right away using these uh, instructions. Okay. Now there are an assignment to connect the PC with the C, right? So PC equal to address C means that the connection or the content of the address here in the PC, even though it's located in different location with C, is actually has the relation or has the address of the C variables here. So C on the other hand has its own value of 22, but PC is equal to address here something which is points, which is related to location of the C variables in the memory. So if you want to write or to know the exact location of a C, just print address of the PC here. Just its a name, the variable of pointer's name, and the content as these two operators, ampersand and asterisk or the indirection here and the address here is complementary each other, so you can print the content of pointer PC, the content of the address of here, the content of the address, meaning PC has the address of C and the content of the address is 22, then the content of PC, which is the address of C, and you mention it by in using indirection operator asterisk here. So the content of asterisk PC, I mean, is 22. Okay, this is quite complicated, right? So once you learn that the all the address here is you want to manipulate all the address here and you relate the address with the some location of a variable or a data, then you can be very familiar with it. Yeah, but firstly maybe it's quite complicated, but it's quite difficult to master. But by doing a lot of practice and uh, take care of all the theoretical aspects, then I think you will understand the whole context of the using of pointers in the programming. Okay. Okay, right. Okay, now you change the C, before is 22, now becomes 11, and then you have the same instruction. Okay, so just if you want to print the address of C, which is already defined here, PC is equal to address of C, then just of course the location will be the same with previous instruction, but now the content is different. Okay, so if you want to make it clear, I think if we look at the program here, okay, now it's become easier to understand if you got the compiler right in front of you, right? So what we have, okay, right here, okay, C equal to 11, and then you want to print the address of it, right? Of course, it will show you the same address with the previous C locations, because you don't change the address, or you don't manipulate the address, just manipulate the content of C becomes 11, and the content of the pointer of C, of course, will be 11, right? Now, if you use this kind of instruction, indirection PC, meaning that please access to the address in the PC has and change the content of those address into 2. Okay, so you just put it asterisk PC, meaning you can read it as indirection PC equal to 2. So 2 will be replace the previous value, which is 11. Now it becomes of course it becomes 2. Yeah. Okay, so let's see how it works and see the compiler, right? I can show you. The first one, the address of C is located here, a certain location in the memory. Okay, 6648180. Yeah, it's a quite because you use the %q, meaning that you unsigned integer, and then you got some value here showing the address of C, and the value of 22 here is shown as before, previously defined before, and then you got also the sorry, the address of pointer of PC here. Yeah, because PC is assigned to address of C, then it show you the same address of C here, 668.4180, and the value of the content of PC is 22, is shown here, and you change C into 12, oh sorry, to 11, and then it changed also the content of the address of PC becomes 11, and finally you change the content of the address showing in PC into 2, then it's the same as you change the C itself, because C already related with the PC here, with the address of the C is recorded in PC. Then you can see that the value becomes 2, and the address of C, of course, the same with the PC, showing the same locations, but the value now changed into 2. So in short, you can see that the difference between, or the notation of asterisk, yeah, meaning you use it as a pointer operator. Uh, you can so write it with space after asterisk, or space before variable names. Yeah, you can choose anything, any of these kind of notations. Okay, so you can see that the asterisk is unary operator, so it's commonly called as the indirection operator or dereferencing operator, and returns the value, the object, into some value by using the indirection operator here. And on the other hand, ampersand is it calls the address or dereferencing operator or address operator. It is also a unary operator that returns the address to its operand, and assuming that the if C has some certain location in the memory, and then you can check the address by using this operator. So if you see here, if you want to see the difference between the address and dereferencing operator, or asterisk sign, you can see that asterisk and ampersand is eliminate. It's just complementary of each other. So if you use these two kind of operator, it equal to uh, in the identity meaning it's the same. Yeah. Okay. So let's see how it affects the using of those two operators together in a variable, and then see that in this case you can read it as indirection of address showing in C, or the address of C, what is the content of those. Then you can see that the result is actually the value of C itself. Okay, let's see, right? So it's means that although you print it as address, but see that the different or the complementary of each other. Yeah. And you can see also, if you want to put ampersand first and asterisk later, the result will be the same. Okay. Okay. Oops, there comes some mistaken here. Okay, let's see. Okay, so I made some mistakes, that if you want to use ampersand first, then you should mention it that the ampersand is looking for address, and the address is content a pointer. So you can see that the address of a content of a pointer is the address itself. Okay. Okay, so let's see the result here. So the address will be shown again. Yeah, like as mentioned before. All right, so let's move on. Now we are going to have some common mistakes that often happen when you use the pointers. First, some confusion if you put the wrong assignment. For example, here PC is a pointer as shown here, right? So PC is a pointer, and C is a integer, ordinary variable, integer variable. So if you just put this kind of, this is the pointer variables and this is the integer variables, then it will be an error during the compilation process. And if you also put the content of the pointer PC here, which is indirect using indirection operator asterisk here, and then you refer it to the address, then it will be wrong, yeah, because PC is a value of it's a variable of pointers, and the C is the variable integer, ordinary variable integer. So you can see the relation is not right, because this is referred to the content and this side is referred to the address, right? Now the correct one is this, like this. You refer a pointer to an address of integer variable, because you already declare it as integer, both of them. And then also you can use some kind of indirection operator here, asterisk PC equal to C, then those two values are the content of the C, right? So now we are going to look at some notes about the difference between pointers and array. So as you already learned before, that array is a kind of a pointer itself, but it has a limitation, which is it has only a fixed sequential elements of data. Meaning, if you have a static one, then once it declares, once you declare an array, then you can change the size of the array. You can use the array dynamically according to your number of data, and it is quite limited only for fixed or a certain number of data. Here you still remember that if you want to use an array, then you have to declare the size in the square brackets here. And if you want to just print the address of those arrays, then you can see that the address can be printed. Just mention the ampersand sign here, the address operator of the array, and the index, right? So when you call an array in a, maybe still remember that if you want to use an array as a, you know, in using function, you can use the array as a parameter to be sent to the function. Then the first address of the array is the reference, actually, for the compiler to know where exactly to put your data or to manipulate your data. And then the other side is just the sequential address according to its size. For example, here character has 1 byte of size. Then you can see that the integer of character, or the character size, is only 1 byte. Then the address is only increasing 1 by 1. So you can see that 6684176 as the first address, and the second data is located in the 7th address, and the 8th address, and the 9th address respectively. So this is the limitation of the array. It has only static one, but you can find that it's quite useful when you are working with the some limit data and some the controlled, for example, some controlled number of data that you want to process. Okay, so let's see if this kind of operator in pointers is working. So if you want to, or to see, if you want to look further and consider the array of integer ARR, or R array is and they only have a 4 in size, and then you want to print the first element, then you can print the array 0. The second element is array 1. The third element is array 2. I'm sorry, this is quite mistaken. And the fourth element is array 3. Yeah. So it is a little mistake here. It should be 2 and 3. Okay. So the address of array 0 is equivalent actually to the array itself. So that's why when you want to send an array to a function, you just mention the array names and the size, and without any ampersand operator. So array don't need any ampersand operator when it was used as a argument to be sent to a function. Just called its name and the size. Okay. Okay. So the array 0, it means that it's equivalent to the array. So that array 0 is equivalent to the content of the array. Okay. So the value of the first address of the pointer of an array, ARR here, is showing by the first element. Okay. So the second element, it should be equivalent to ARR plus 1, and the array 1 here, the second element is equal to the content of the array plus 1, because the array has the first address. Okay, so the first address is the main reference for the compiler to process your data. It means that if you call an array by saying its name, for example here ARR, so it refers to the address of the first element. How about the second element? It depends on the size. If it is on the integer, maybe the next 2 bytes will be the second element, and the next other 2 bytes is the third element, and the last one, next 2 bytes will be the last element. So it means that array is also considered as a pointer, but in this case it's a very static one. But we can also use it in many applications in your program. Okay, let's say an example here. So the example showing that you have classes, an array of integer. It has 6 elements. The sum is 0. So this program is quite simple, just summing all the elements in the array and print the sum in the end of the program. Okay, here. Okay, so this is the looping here. So just scanf, it means that you have to input the element one by one through your keyboard or input devices. And the class plus I means that equivalent to actually the address of classes of I. Okay, so it means that if I equal to 1, that it is actually it's the same as the address of the classes first element plus 1, meaning the second element. Okay, and this operation is looped 6 times, okay, according to the number of the element of the classes, and you sum it. Okay, how to sum it? Just sum of sum equal to sum plus this quite unique writing. Instead of you use classes, for example here, if you make it in another statement, sum equal to sum plus classes I. Here you just mention the content of the array name, meaning that you can see that the array is actually a pointer here. Okay, without any square brackets, right? Square brackets is just for showing you the index, but if you want to make it the pointers, you have to mention the locations, the exact locations of those variable. So if classes is always uh, increased by I, it means I is from 0 to 5, yeah, then you got all the 6 elements summed. Yeah, summing in this in the end of the program will be printed out, and then you get the result. Okay, all right, I think let's see the example in in C. Okay, this one. Okay, so if you have the scanf of classes plus I, meaning that you have the classes is a pointer of array, right? Integer, right? Has 6 elements inside it, and then you have the first address pointed by classes and plus I, meaning that you have the first address plus 0, the first address plus 1, first address plus 2, first address plus C, etc. until plus 5. And then you get all the data inputted from your keyboard, and then you submit, and then you just print it. Okay. When you see that this operation is quite, for example, 1 2 3 4 5 6, let's do it this first case, and the sum is 21. Then you still remember that you can also change this scanf classes plus I using the classic one, right? Classic one is classes I, right? All right. So let's comment it. Is this one, and the summation will just classes in square brackets I, right? So remember that? Sorry, this is unended brackets. Okay. See? So it looks like the same. Not it look like it is the same by the previous statement. So, all right, some kind of mistake in here. Forgot to put the close brackets, right? Right? See, it's the same, right? 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then what happened? Okay. All right. I think something's wrong here. Okay, let's see. Sorry, I forgot to put ampersand sign, because if you treat the classes as an array and as an is integer variable, then you should not forget this ampersand element in scanf. Okay, so just fix the program, and then let's see the result. So we put the same data and get the same results. Okay, right. So this is another thing related that all the array is actually pointers, but they have the static size, the static number of elements. Then you can use it in a certain kind of computation. But if the data is very dynamic, you don't know the exact number of the data. It can be small, it can be large, or it depends on the needs of the maybe of the user. Then it's better to use pointers directly. Okay, now let's move on to how pointers used in the function by uh, calling them by reference. So, do you still remember that there are two ways to pass arguments to function, right? The first one is passed by value, and all the examples that's shown in the previous lectures is actually only passed by value. Now you can use the pass argument to a function by reference. You call it by call by reference or pass by reference. So functions often require the capability, or you want to change or to modify variables in the caller or the main program, and you have to use direct referencing and direct access to those data, especially when you deal with a large of data. And instead of you just call it by value, it means that if you work with call by value in function usage, then you send the parameter to the function, right? And the function do some calculation, right? And then return back the value and copy it to the main program, right? It is just, sending something and then get the result and copy it into the main in your main program. It kinds of some, incurs the time and memory overheads, right? Because you are making a lot of copy of the object, especially when you deals with a large data. Okay. Okay. So in this case, let's see if you have a function to swap two numbers and using pointers in it, right? So in this case, principally, it's in C programming. If you use pointers and you use the indirection operator, indirection operator means that you use the symbol of asterisk here. This is the indirection operator, and then you call the function, basically by refers to its address. Yeah. So you are working with pointers in an effective way or in the right way. Okay. So just think that the pointers have address and have the location and have the content, the value, right? So if you deals with some data manipulation, just remember what kind of the data it is, what the type, and use the pointer to access to those data, exchange the data, manipulate the data in the functions, and return back to the main program with the not a copy one, but it's only the direct changes of your those values. So it is quite effective. Yeah, there is no overheads in memory, of course, in time of processing, and quite useful when you deals with a large of data. Okay, so let's see the example here to swap two numbers using pointers and functions, and let's see the example in C programming. Yeah. All right. So to swap two numbers using pointers, just call it void function, for example, swap, because you just only to exchange those two variables value, and you declare the function names as usual and the parameter or the arguments that you want to send to the function. In this case, all those are pointers, right? So two variable pointers will be exchanged, and depends on its address, then you can exchange also the contents based on their addresses, right? Okay, so in this case, you have two variables. Num1 is 5 and num2 is 10, and you want to, of course, maybe you want to make sure that those value is not exchanged. Just make sure that to print it those two numbers here by using printf instruction here, and then do swap, right? Swap of the address. You see that how to exchange two variables. You can exchange it by exchange those value using a temporary variable, but also you can also exchange the address, right? So check the address and then see the content, and then swap its contents each other. Yeah. So swap is a, the function itself should involve the ampersand variable or the address operator. Yeah. So just remember, in principle, if you want to use pointers in function, all the variables here should be pointers, right? But if you want to use it, use the function here. Remember, all should be all addresses, right? Okay, so the function itself deals with the pointers, and the function is deals with the address. Sorry. Okay, right? So in the function, you can see that there are three variables. There is a temp, because if you want to swap something, you should put it in temporary variables first. And temp is equal to in direction n1, meaning n1 is the first variable should be put here. Yeah, no problem. You have space between variables or no spaces is okay. So temp will be equal to content of the first element, the n1, the first content of n1. It will be put in temp, and n1, the content of address of n1, equal to of the content of the address of n2. So if you send the address of those two variables, the first address will be, the content will be put in temp, and the second content of the second address will be put in the first address, and the second address will be equal to temp. Okay, the content of those addresses, right? So by doing this, you have to the swap already done, and you can print it after that by showing the numbers, right? Okay, let's see how it works. Okay, so before swap here, you can see that the number 1 is 5, number 2 is 10, and after swapping, the those two values are exchanged each other. Okay. Okay, so this is quite simple. That just please always remind that if you want to do some, modular programming using pointers, then all of the functions should be deals with the pointers, right? And to use it, you deals with the address. Okay. So just remind that using pointer actually is like opening an envelope, a letter. In the letter, usually you write the address, you write the name of the your friend that you want to send the letter, or you just mention the city and the street, and then and also the house numbers and etc. If you want to also send an email, you just deals with the email address, right? You want to send some WhatsApp, and then just contact the uh, your friend's WhatsApp number or lines or any other communications. You just actually in daily life with some addresses, right? So in every address and every data, you mention the address, you mention the name of a people, then you mention the nickname of your friend. Is kind of a analogy with the pointers in the C programming. So when you deal with the address, please be careful not to send it to the wrong person. For example, if you want to send something, a WhatsApp message to your friend, for example Dodi, just make sure there are no other Dodis in your address, contact address, right? Or contact number. So if you have the double names, and just to make it different name, or use another nickname or other addresses or other sign. Yeah. So this is a very normal life, deals with address, so don't make you confused. And hopefully this kind of explanation can motivate you to do a lot of practices using pointers. Okay. Right, let's see an exercise here. This is a development of the previous program using swap, but this is a kind of special because you are doing cyclic swap. Yeah. Cyclic swap meaning that if you have, for example here, if you have four elements here, n1, n2, n3, and n4, which initial content of, for example, this is a 5, sorry, and 5, 10, 15, and 20, and do some swapping that makes the fourth element becomes the first one, and the first element become the second one. Yeah. So like just like moving to the right side, right? But how about the last element? The last element should be go back to the first element. So that's why we call it a cyclic. Yeah. Cyclic meaning that it's rotate. Yeah, rotate once, rotate twice. It depends on your need, right? So this kind of, data manipulation can be uh, constructed in a very efficient way using pointers. Okay, so in this example, let's see there are two functions. The first function is swap itself that you already previously used. Yeah, exactly the same. But the new one is the void cyclic swap, meaning that there are several types of swapping process here. Yeah, just look at the structure. The structure is started by swapping the third two and the third and fourth element each other. So the first one is how to exchange the 15 and 20 first. So 20 will be moved to this location and 15 will be there. Okay, and then the next step is swap x2 with x3, meaning that the element of the second and the third will be exchanged each other. So 20 will be moved here and 10 will be moved there. And finally, it swap with x1 and x2, meaning that 20 will be the n1 and 5 will be the n2. So this kind of cyclic rotation is kind of right cycle. But if you want to make it to the left cycle, just think about the order. Okay, you can think it later on, because this is the cyclic swap is a right rotation, right-wise rotation. If you want to make a left-wise rotation, then you can imagine, right, which one should be exchanged first. Okay, so it is kind of a interesting idea if you have the algorithm for that. Okay, so let's move on to the new topic. Actually, this is quite related with the pointers, because it is also an important facility or important technique in programming. You know that creating and maintaining dynamic data means that the data structure should be flexible. You can grow it or you can shrink it at any moment. Then the program runs uh, do some kind of dynamic memory allocation also. So if you have your data in your programming is quite dynamic, then you have also use dynamic memory allocation for that. So all your data will be put in the right order, and you don't have any problem to manage all of those data. And memory space also can be saved, and you can also see in this explanation later on when we deals with free. You can also deallocate, or you can also remove all the allocated space that previously used. Okay, so actually C doesn't have any technique to allocate memory dynamically, right? So you have to use a special library for that, called standard library.h. So if you include this library, then you can use the allocation, or the dynamic memory allocations, right? So there are four functions here. Uh, actually, Also, additional function, maybe you still remember it, size of. Okay, so it's also a very important one, because if you want to allocate something, then you have to know the exact size of how much memory should be allocated for you, for the compiler, right? So this is quite an essential for dynamic memory allocations. So the first one is malloc. Malloc is the function to allocate requested size of bytes. Size of byte meaning the size of the data you want to allocate, and returns the value of malloc here as a value that showing the first byte of allocated space, and also the all the values should be uh, initialized as well. Okay, and the second one is the calloc. Calloc is quite different with the malloc, because the calloc is allocate space for contiguous allocation. Contiguous meaning that, or consecutive, yeah, consecutive allocation. So you some kind of allocation space for like an array, but it is very dynamic one, right? If you just define an array, then it is very static. You can change the size at any time. But if you want to use it in a dynamic way, then you can use calloc instead of array. Okay, and it initializes also the zero or the value of the array and returns a pointer to the memory as an address, the first address. And the third one is free. Yeah, as I mentioned before, that if you want to use the memory more in very efficient way, then you have to deallocate, yeah, the previously allocated space which is no longer used, right? That's why if you have the needs of very large data, and then it is quite useful that when you see uh, there are data that no longer used and is no longer related what you want to process later on, then you can just free the allocation. And the fourth one is the realloc, means that you can change the size of previously allocated space. This is quite dynamic uh, function actually. All right, so let's see the first one. This is malloc. The syntax is simple. Just define the variable that's showing the allocation of the address that you want to allocate, and the cache type, meaning that you want to uh, decide what type of data, of what size of the unit data you want to allocate, and also the malloc itself as a command, as a syntax here, and the byte size. Yeah, the byte size may be using size of, right? Size of integer, size of float, and size of anything, because it is quite useful when you don't know the exact size of integer in your computer or in the user's computer, when you want to do a program for other or for a user requirement, then yeah, it's better to use a size of instead of a certain bytes, right? Okay, so we call the ptr here defined in this syntax as a pointer of cache type. So you can read the statement as ptr is the pointer of cache type, which is allocated as, or has the size of something size here. Okay, so the malloc function returns a pointer to an area of a memory with the size of byte size, which is declared here. If the space of the memory is insufficient, which is a very rare case, but it sometimes happens, the allocation will be fails, meaning that it is not successful to allocate so the needed space for that, and returns null pointer. So it is quite useful when you are doing with malloc command, or in the very dynamic memory allocation to check whether the malloc has the null returned back to the main program. It is a returns null, then it means that you don't have any sufficient space in the memory for your needs. You can check again the program, or you can check again the needs of your data, etc. Yeah, you can see that it is quite useful that you check the malloc return value. Okay. Okay. In this example, let's say the PTR is pointer of cast type of integer here. The size is 100 times size of integer, meaning that the size of integer in your compiler is only 2 bytes. Then there are 200 bytes. But if in some compiler or in other computer operating systems showing the integer size is 4 bytes, for example, then you got 400 bytes for that, right? And the PTR itself, as initial value, is the address of the first byte of the memory. So you can check the address using the value of PTR for the first time. Okay. All right. So the next one is calloc, contiguous allocations. Right. So different with malloc, which allocates a single block of memory, meaning that 400 bytes, 200 bytes, it is a single one of memory that you want to allocate. The calloc can allocate multiple blocks of memory like array, right? So each block has the same size, and all the value in the blocks set automatically to 0, so you don't need any initialization for that. Okay, so the syntax is same with calloc. I'm sorry, with malloc. But in calloc, you should mention the n, meaning that you want how many contiguous space in memory you want to allocate, or how many elements of the array. In this case, if you want to process it like an array, right? And the element size, yeah. So in this case, for example, PTR is a cast, you know, uh, is a first address, or it's a refers to allocation of contiguous memory, which has a float type of the array, and it has 25 elements in it, and you have the size of float as the element size. So it depends on the each compiler or its operating system. uh, it can be 4 bytes or maybe different size. Okay, but is in this case it's like you just define an array with 25 elements with a float size, yeah, and then you can allocate it in the memory before the program is processed. Right, the next one is free. Free is a command to deallocate or to release or to uh, empty or delete the memory allocations dynamically. So all of the memory allocations actually created either with you use malloc or calloc is not get freed on its own. So if you still run it, then run the program, then it still existed in the memory. So you must explicitly use free command to release or to deallocate the space. It's very simple syntax for that. Just free and the pointer's name. Okay. So if you want to free it, then the memory will be emptied. The block will be erased. And then if you are trying to refer to the memory that has already freed, it's an error, right? And sometimes the the effect is even worse, can be result in the program crashing, yeah. Or if you you know uh, forget to free some pointers that are not already used anymore, then you can see that the memory size is very limited resource. Then sometimes you have run of memory prematurely, yeah, before even the program has already finished perfectly. So this is some occasion that called a memory leak. Memory leak means that you're not freeing dynamically allocated memory that's already defined when it's no longer needed, when it's no longer used, and the system has no space for processing your data further. So it's a please be careful when you are working with this malloc or calloc. Just remember that your memory is limited, and maybe your computer has a very big one, but maybe your customer or your user has a really limited space. So please be careful. Okay, let's see some examples. All right, the first example here showing how to use malloc and free after all of the pointers are used. So in this case, in this program, just see that you must include the standard library.h because malloc and free is a dynamic memory allocations, which is library standard lib.h has it. So you include it in your program, and this is the PTR is the pointer for the memory allocation later on to be used, and you just sum the numbers if you want to do some summing the elements of the array or the variables. Okay. All right. So the important one is this declaration. PTR is has the type of integer or pointer, and it should be has the size of num. Num here is a number of elements inputted by the user, and size of integer is the size depends on the compiler, the size of the length of the data of integer, maybe only 1 byte or 2 bytes. So if pointer showing null here, meaning there are no space available that you want to allocate, then just print some error message. For example, error, memory not allocated, or memory not enough, or lack of memory. And then if not, if this declaration is no available, is no null value, then you can move on to enter the elements of the array, starting from the first element until the num of elements. Okay, and after that you can sum it and print the sum, and don't forget to free. Right, at the end of the program, don't forget to free it, and your program will be successfully run. All right, so in this case, see the example here. All right, let's see further that in this case the element is put into PTR plus I, scanf, right? Scanf of PTR plus I. See that since the PTR is a pointer, then you don't need any ampersand here. You don't need it, right? Okay, just PTR plus I. PTR plus first integer plus 1 plus 2 second integer plus 3 the third integer, etc., and then you get your data inputted to your program. Okay, let's see the results. And number of elements, yeah, I think I just need only 3. Okay, the first one is 10, second one is 20, third one is 30, and the sum is 60. All right, and see that there are no errors, yeah, because the size of integer times num is still not a big numbers. so you don't have to worry if your data is only a small one. Okay. All right. I think it's clear. Uh, Then the next one is the second exercise deals with calloc. Yeah, calloc is also same with what I mentioned before. So it is precisely the same. Yeah, except that the calloc instruction is showing how many data should be allocated. So it depends on the number of elements inputted by the user, and the rest is the same, right? Scanf ptr plus I, and sum the content of the ptr plus I, and then do the summation until the end of the data, and then print the sum and free all the pointers that already used. Yeah, so I think it's quite the same using calloc, right? So if you see, there are no difference between the previous example. Yeah, except that the structure of calloc should mention the number. The malloc previously is num times, right? So remember, num malloc in brackets num times size of integer, right? Yeah. Okay. Malloc num times size of integer. In calloc, num comma size of integer. So you don't need any multiplication operator here. Just mention the number and then the size. Okay. All right. The result will be the same. Okay. I think I have to put the same numbers and the same sum. Okay. Right. Okay. Let's go to this third example using realloc. Realloc is, if sometimes if you allocate memory and then it's insufficient, I allocate only a small number. I need add. I need addition. Data size, and then you can use realloc here by using this instruction ptr. Oops, I'm sorry. Ptr is equal to realloc, and then in brackets is the name of the pointer followed by the new size, right? So it's quite clear that if you want to have some additional uh, memory allocations, and there are some trouble when you want to make another uh, allocation or another additional size, then just mention the realloc instruction here. Okay, let's see the example in C. I think I should close this one. Okay. Okay, realloc is used when you want to change the memory allocation size, which is previously maybe defined by malloc here. So the first one is enter size of array, and you put n1 here, the size of the first array, and you malloc n1 times size of integer and put it into pointer. Oh, I want to new size. Okay, so just scanf the second new size. It is n2, and using the same pointer here, so realloc the ptr and the size, right? N2, right? So malloc instructions followed by realloc, meaning that the first allocation will be changed into the second allocation using realloc, right? Not edit. Please remember, not edit, but it is changed. So if you want to change the size, which you think it later on, this is quite big data, and then you want to uh, make it the program more more flexible, and you want to allocate more space for your array or your data, then you can use the realloc as a command to change the memory allocation previously uh, declared with malloc. Okay, so this is quite a flexible one. So if you want to try to run this program, because it's only using the ptr plus I, meaning that you want to see the address reallocation, because you want, if you want to make sure that the data is already changed, just check the address. Okay, check the address, it is increased or not. Okay, the first one is n1, and put and then printf the address of ptr plus I, and the second loop is looping until n2, because this already reallocations by n2, and you print the address. Okay, so if we run the program, then maybe first one is 10. Oh, see that these are 10 addresses, yeah, space separated by tab. 1 2 3 4 5 6 7 8 9 10, right? Okay, so you want it to change to 20, right? Then you have 20 edit address, not edit, change address, because the exact first address is the same, right? The same. Previously only 788 here, and times there are 4 bytes addition, because in this compiler the integer has 4 bytes size, yeah, and until 20 of addresses showing here. Okay, so this is a quite beneficial if you want to maybe change your mind that the data is not enough, so you want to change it into a larger or even the smaller one if you think it is too big in the beginning of the program. Okay, all right, so let's move on to the example of using the dynamic memory allocation, in this case using calloc, to find the largest elements here, the largest elements, meaning that you want to compare the data one to each other, and then find which data is the largest and store it in, or print it to the user. And in this case, it's quite a simple one without any function used in this program. So using calloc, so you want it the location of the memory is consequently located, or it's a contiguous allocation. So the first one, you want to print the total number of elements. For example, you limit only to 1 to 100, and you scanf the number of the data, and you have a pointer of data. It is a type of float, because your data will be uh, a float of size, because maybe the user wants to uh, store the largest data in float format, and then because the data itself is a float now, so and if you calloc it using a num and size of float, yeah, allocate, and then the compiler will allocate the memory for num elements. If the data is null, meaning that is memory is not enough, or there's some problems in the memory allocation in your compiler, and then you just enter the number of the data using scanf and data plus I here as the variable for data entry, and after that you exchange one to another. Yeah, if the data comparing to the next data is less, meaning that the data plus I is larger, then data is exchange change to data plus I. If not, then do another repetition. Okay. And finally, at the end of the program, the largest element of data will be shown. And in this case, you forgot to free the the pointer you allocate, right? You should free the data. Yeah, sorry for that missing important thing to do. Yeah, so I'll put it in my program. Okay, so after using all the allocation memory, don't forget to free the PTR, right? Right. Okay. Oops. No, the PTR, the data. Okay. So let's see the program run. For example, you put 5 elements and maybe I'll just look at some random data. All right. So the largest is 443 because I put the largest number in my typing or my data entry is the third data is 443, right? So it's quite useful that if you want to do some calculation and do some data processing, do some sorting, do some comparing each other, or do some analysis, or do some calculation, multiplications, or maybe summing, adding, yeah, adding something and then dividing something. Use the flexible one using pointer. It is quite dynamic and you don't have any limitation for your variable size or your data size. So I think it's quite beneficial for you if you can master the basic usage or the basic principles of pointers, because this is very advanced, even though there is a quite complicated at the beginning, I think. Okay. So let's now go to our exercise challenges. And in this course, I only give you one challenge task. You can see in the slides or in the video later on. This is a kind of calculation of 2 n factors. 2 n factors meaning there are 2 factors which is uh, you know transpose each other, and then you have to operate it in a scalar product here. Yeah. So this first scalar product and the second scalar product should be uh, you know transpose each other, the number of elements, and you get the result of those uh, you know uh, products. Yeah, I can say this is some kind of multiplication, but this is quite beneficial when you deals with the factor operation. Okay, so use pointers. Don't forget, use for pointers for that, because you are have a very dynamic array size and dynamic memory allocation to store the factors, and you can see the flowchart like here. Okay, I think this is the end of our course, because you heard that this time prayer for now. So I think I'll end our course for today. So good luck with your challenge. Do your programming practices. Do dynamic allocation of memory utilizations, and have a nice time with your programming skills. Okay, guys, have a fantastic time, and see you next time. And if you have some comments, questions, and remarks, please put it in forum in the channel at Amas. I think I'll load also the video in Amas, and you can study it further. Okay, until next time. Thank you. Goodbye, and good good morning, good afternoon, good evening, or good night. Have a nice time with your lectures and your family at home, and stay healthy and have a good times. Thank you. Bye bye.